Alright, so in today's video, I'm going to show you how to create this dynamic facade. So we'll start by creating the base form for the building. And then at the end, you'll see how I created a curve attractor. And this is going to allow for the pattern to change dynamically depending on where that curve is located. So if you want to learn a few more tips and tricks on how to use Grasshopper for architecture, I'll be going over all of the steps in detail. And if you get stuck somewhere or you want to see how things get plugged in, you can always download the script from my website as I post this video. So thank you very much for being here, and let's jump right into it. All right, so to start, let's bring in the first component, which is going to be the rectangle component. So let's go to this one, which lets you plug in the X and Y size. So let's create two sliders, for one for the X and one for the Y. Next, we're going to extrude this for the first floor. So let's go here to extrude. Since we're going to be extruding it, we need to give it a direction. So let's bring in the Z vector. Now we can extrude this up. Now I use the slider, but we can bring this down here. And this is going to be the first floor. The floors above, I do want them to be offset. So what we need to do is bring this rectangle up to that first extrusion. So we'll bring in a move component, also bring in the rectangle component up using a move and this Z vector. Now we've moved the rectangle up to this location. Next, we're going to offset this. Let's go here to offset curve. The distance, we need to plug in a value. So let's go here to 120. And now we're going to be creating a surface between this one and this one. So we'll use a boundary surface between this and this one. And then we'll flatten the input. So we look at both of these as one set of curves in one component here, and then it will create that surface between those two. Now we can extrude this one up in the Z direction. So let's copy this portion because that's an extrude in the Z direction, and we can copy the slider as well. And all we need to do is override that rectangle with this offset. So let's decrease this maybe to a smaller amount here. Now for this design, we're going to be doing it in a simple way. What I mean is we're going to be creating where the floors are. We're not going to focus on the interior design. The floors are just going to be there to show you where we can anchor the facade onto the floors. So we'll go back here to this component, this offset, and we're going to bring the midpoint by using an area component. And then we're going to be creating contours. Starting at this point, the shape is going to be this extrusion. The direction is going to be vertically, so using Z value or the Z vector. And then the distance is going to be the spacing between the floors. So for that, we'll use another slider. Now we can take these contours and use a boundary surface. And we can extrude it up more. So let's change this to maybe something more. Let's do 150. And then we can extrude the surface using the surface as the base input, and then a Z value to extrude this up by a slider. So now you're seeing that we created the base location, then the offset for the top floors, and we created the floors going up. The idea for this is that we're going to be creating a dynamic facade. And so for that, we need to know where the floors are so we know where to locate the connections. Next, what we'll do is pick one of the surfaces. So let's go back to the extrusion, this one, and let's use deconstruct brep to be able to pick one of the faces. So we'll plug in that extrusion into deconstruct brep and use list item to pick one of the faces. And now we can hide both of these, as well as this set of surfaces here. The next component we're going to use is isotrim. So we'll bring in isotrim. And with isotrim, we bring in divide domain squared. Now what we need to do is plug in the surface into both the surface input and the domain. And now we have a U and V subdivision. Now for this one, we do want the, let's see if it's the U count to be 1 and the V count to be the way that we'll connect it. So it's going to be the vertical subdivisions that matter the most. So let's go here to, let's create a custom slider here. So we'll go 4 or 3 less than 10 less than 20. So now it sets it at 10, but we can always increase the number of subdivisions here if we want to. Next, we'll take these surfaces and offset them. So we'll go here to offset curve. And even though these are surfaces, it will use the boundary of that surface as the curve input. And we do need to offset it to the inside. So we'll bring in a negative component and use a slider to offset it to the inside. So let's go here to 2.50, giving us a little bit more precision using 2 decimal points. Now we can also use the surface and this offset to create the surface in between, but I do like to offset this one by 0. And what that does is make sure that since we're using the same components, it will organize the information in the same way and allow us to create a boundary surface between those two. So now I can hide all of this, including the original surface. And we have this frame that is created from the top to the bottom. And now we can use this to extrude it. Now to extrude it, we do want to use the normal from this surface. What that means is perpendicular to the surface. So to do that, we can use evaluate surface, reparameterize it, and then use the point as the middle. So to create a point, we'll do 0.5 comma 0.5. So that's 2 x and y values. And since it's at half and half, it will put it right in the middle. And we have a normal here. And we also have a frame, which is a surface that we can use as with an amplitude component. So we'll use a normal as the vector, and we will extrude this surface using this vector and this base geometry, and now we can use a value to extrude it. Now it extruded to the inside, so we do need to either use a negative after the vector or before. And we also need to use this number that we used to move it or to extrude it, but to move it, move the original surface out to that location. So we'll take this surface and move it using this vector. So now no matter how much I extrude it, it will move that surface to that same location. So for this one, I'll use a geometry component and a custom preview so I can visualize the frame. And I can hide these two and just see this one, because now we're going to be creating the pattern right on this one. So the next move is going to be to take this outside one and subdivide it. Now for this one, I'll be using Lunchbox. So I'll use Lunchbox as well as triangle panels B. And so I'll use this geometry as the surface input. But what I want to make sure to do is that these intersecting panels land exactly near one of the verticals. So the way to do this is to make sure that our U or our V needs to be, or our V count here has to match with the V count of the isotrim. Notice that now they match, and what we need to do here is, if we want the density to be larger, we'll take this we'll create a relay here, and we can multiply by 2. And we can make this slider to be even numbers. And the vertical subdivision, or the U, we can use a slider here between, let's say, 10 less than 20 less than 50. And for these other panels, it doesn't really matter where it lands. The ones that we'll be connecting are going to be the vertical ones. So with this, we can actually figure out what density we want. So let's make it here with 20. So now we can hide this surface. And what we'll do is something very similar to what we did with the back frame, is we will be offsetting them, creating a surface, and then extruding it relative to this vector. So what I'll do to make it a little bit more efficient to create this, I can copy all of these, but the important thing is to create a relay out of this surface, because I know this goes into both of these. So I can copy this, basically the slider, the offset, the surface, the extrusion, and all we're going to need to do is copy this portion, which is going to be different. So we'll take this, slide it down to where you want it, tap Alt, it'll create a copy. And now we can copy this extrusion, basically the vector and the amplitude, override the input here, And now we can use, well, we're going to be using the same vector because it's going to be that same surface in the back. And we can use these panels as the input. So now this is hidden. So let's show it. And let's decrease the offset. And let's decrease the extrusion. And now let's bring in a custom preview so we can see it a little bit better. And also copy that geometry component. So this is what makes it a little bit more efficient, is if you know the steps that you're going to take and they're the same ones that you've done in the past, then you can override those and copy them here. We can also go back to that original frame, maybe offset it by less. So let's go here to 1.5, extrude it here by 3. And then we'll go back to this one. We'll offset it by 3. And we can even just keep it the same color if we want. Let's actually change it a little bit here so we can actually see the pattern independent from the back supports. And we can also hide this input. So wire display hidden. Let's go back and, well, if we set it at even, we can't pick 1. So we do want to pick 1 for it being the same, and then maybe less here. Here we have 12, 2, 3, 4, 5, 6, 7. 7 floors. But they do land in a similar location there, so that's good. And then here, we can always offset it more. For this next part, we are going to be creating the dynamic portion of the facade. So we need to go back to the offset. So this one, because that creates the panels on the inside. And what we'll do is use that and offset it again, because we'll be using a curve attractor for this one. So we'll offset it again using an offset component. And I like to offset it by 0, like we did with this one. And now with that, we'll be creating a loft. Now notice that these panels are going to be offset to the inside, and here they get a little bit smaller. So that's something to keep in mind. And now we'll be turning these, this one, as well as this one, using a curve attractor. So let's hide this. Let's bring in a custom preview for this one and for this one. So this one is going to be for the glass facade, and this one is going to be for the inside frame. So we'll just change it a little bit here. Now the idea for this is that first we need to move these panels. Why? Because they're lining up exactly where those are, but we can also just extrude them. So we'll actually use an extrude component, which is the same one that we have here with this with this amplitude. The vector we can keep. We'll just hide the wire display for the input so we don't have it going crazy here. And then we can extrude the loft and now override the input. For this one, it's going to be a little bit smaller. So we'll just do 1.5 and do the same thing, but now for the glass. So I'll copy this down and use the surface input and override the custom preview with the glass. We can always come back here and change our input for the subdivisions. Now for the curve attractor, what we need to do is get the exact center of these panels. So there are different ways where we can extract that. I'm going to extract it from the surface here, bring in an area component. And where these points are located relative to, I'm going to go back all the way to the beginning because we can use any of these steps. And I'm going to use this offset curve, which we offset to the outside, and I'm going to move this vertically. So using a move component, we'll use this offset curve and move it in the Z direction. So this moves it all the way up, but notice that I can move it anywhere between the top and the bottom. So let's move this somewhere here. But I'll bring this all the way to the end because now we need to evaluate between all of these points, which need to be flattened first of all. I'll hide the wire display on this one as well. And now we need to evaluate how far this curve is from all of these points. So we'll use curve closest points. So this curve is going to be the curve input. These points are going to be the points that are going to be calculated as to how far this curve is from all of those. And now we can move this. Now what this does is instead of having an offset here that's consistent, we're going to have a variation. So we also need to know what's the maximum here. And the way to do that is with this slider, we can go here and change the max to 20. And we can see that about the maximum is going to be 17 or 18. So that's what we'll do. We'll make max 18, and then the minimum is going to be 3. The reason why is because here now we have the variation in how far this curve is from all of these points, and that's what's going to allow for the curve attractor to work. Now, what we need to do is take these numbers that are too large. 1 is 41, so we know that's too large. The maximum we need to have is 18, and the minimum is going to be about 3. So what we need to do is take all of these numbers, which we can also see with the panel, and we need to remap numbers into a smaller minimum and maximum. So now we'll use remap numbers bounds and construct domain. So those are the three components you'll need if you want to remap the numbers. So construct domain. So this distance will go into the values, which is going to tell it the original values. This distance goes into the bounds, which tells you the minimum that it is now 10 and the maximum is 805. And the target is what we want them to be. So we're going to go start at 3.00 or create a slider between, let's say 0. We don't want it to be 0. 1 less than 18 or 18.000. So this will be the first one. And the next one will be 18. So now when we look at these numbers, we'll see that they won't get any larger than 18. And we can also see that when we copy bounds here, and we see that the minimum is 1, the maximum is 18, as we set in here. Now the difference is that we now need to take all of these numbers, this output, and we need to bring it back to the offset. So notice that it's not working, and that's because now we need to decrease and increase this number here. We actually can't do that, so let's bring this back. And what we'll do is use the centroid from portion back here, which is basically the same. And then use these map numbers. So let's hide the input on this one. And use these map numbers as the input. The other thing is that these are grafted sets. So we need to make sure that these are going to be flattened and these are going to be flattened. So since that was flattened, we'll do that to this one. And we'll do that to this one. So now let's change the maximum here, the minimum here. But on this input, we will graph them here. So using So it's working, but now we have this issue here. So let's see what that is. Well, instead of doing that, we'll just use a boundary surface between those two, which will be the same thing. And then use this input. So flatten the input on this one. So the issue was that the offset couldn't be the centroid. It had to be a portion before this. And also that the way that you create the offset, both of these sets need to be flattened because these are a flattened set. So it's a long list, and this also needs to be a long list as well as this one. And now it's all kind of working here. That's a bit of mistake on my part, but now let's see how we can change. Let's see the maximum here. Let's go to 20. And how far this line segment is going to determine the gradient. If it's at the top here, The further away it is, the closer it is, the smaller the offset. The further away it is, the larger the offset. And we can control that using the minimum and maximum. Now we can do the opposite as well. We can go back here to a smaller number, and then this one to a larger number. Now we can hide all of these. Now the offset's also dependent on the pattern size. So if you make it a smaller pattern, well, the offset needs to be less, right? So if we go back here and we go, this pattern's going to be twice as dense. And there's going to be more subdivisions vertically. What this does is makes us go down here. Notice that this is not working. Well, that's because now we need to make this a smaller number for it to work correctly. And also, more subdivisions you have, the harder it is for your computer to calculate. So notice this one is way too small. Let's go to 10. Still too small. That's mostly going to be for these outside ones. It will still create the surfaces where you need them. Let's just decrease this. That was just an example of how this was going to work. We can always go back to something like this. And then this one back to 1. Let's go back here and change this again. Here's the other thing. You can also create a gradient that is, let's go back here. We have this as a vertical or horizontal gradient, whatever way you want to look at it. But we can also create one vertically, let's say from the center of the top here to the center of this one. And then it will change the pattern on each side. So now here towards the end, if you've been wondering, well, all we've done is one side. Can't we do the other sides? Well, that is one of the great things about when you do the script for one, and if you've done things correctly, you can do it to all of the other sides. So we picked only one surface here, but if we go to this list input, now keep in mind, the larger the subdivisions you have, the harder it is to compute this, and it could even crash your computer. So also, if you haven't done this correctly, this portion here, you can also crash your computer because it could cause some computational issues. So just keep that in mind. For now, save it if you can, and then go here to the list input, and then go to graph, and it will do it not just to this surface, but to all the surfaces around. And we should still be able to change the location of our curve attractor. Now it's just going to be more difficult for it to compute, like I said. So let's go back and change it just to 1. The other thing is we could, if it's a symmetrical building, you could rotate this around. So that's the other way of doing this. So let's go back, change this to be at the top. Let's change some of these, and so the way that this is created is, let's hide this surface here so we can see it, is that we have these verticals that connect to the triangulated panels. The triangulated panels are there to then hold these other panels that will be either larger or smaller depending on the curve attractor. And then we have the glass panel to let light in. So now if you like the way that it's looking here, let's increase this even more than 18. And even though let's see where the curve is, bring this up further. And even though this offset is not going to work because this is going to be a solid panel, we can still take these outputs, bake them. So middle click, bake. I'll group them together. And then also go back to the floors. The first floor, and bake it. And then I'll take this and move it to the side. So I'll decrease this now to make sure that it works. I'll save it. And since I grouped these, and I know that this is a symmetrical building, I can create a diagonal from one side to the other and rotate this relative to the center point. Copy, yes. And then create 4 copies. Even though we could do it parametrically, this will actually make it easier for us to not have to crash our computer. So that concludes the tutorial. What I showed you was to create the base form, but that wasn't really the idea. The idea was to create a subdivided facade that can be attached to the building, and also show you how to create a dynamic pattern, which comes down to using a curve attractor, but also being able to remap the numbers for them to be variable and for them to interact with the curve that you created. So with that being said, that kind of concludes the tutorial. Hopefully you learned a few more tips and tricks. If you have any questions, you can always download the script as I post the video. And that way, if you get lost somewhere or you want to see how I created it, you can check that out for yourself. So thank you very much for being here, and I hope to see you in the next video. All right, so what I've done here is I'm going to take this design And I'm going to now go back to our render mode. And I'm going to take a capture of this and try to use an AI render to see and visualize what this would look like. So let's take a capture of this. I'll go right click here, capture to file. I'll make sure that the resolution is a fairly high resolution one. And then go here to my render folder and use a capture folder. So I can now save it here. Now it's a good idea to get a few different views to see which one is going to look best. But now that we have this, let's go on to ReRenderai and let me show you what I do to create my renders. So now that we're here using ReRenderai, let me show you what I do here. So I start by going to the render tab. Now I'm going to go back to my project file and folder, and let's see where I have my capture. So let's go here to render, capture, and then I'll just drag and drop it into the image location here. Now I'll go here and figure out what kind of style I want to create. So I'll go to type options, go to commercial properties, and I'll just go here to office building. Then I'll go here to high tech. Time of the day, I'll go midday, summer, clear sky, cityscape. And this one's going to be steel, but it's going to actually be steel and glass. So we'll just use steel for now. And then in here, I'll use the prompt to describe what I have in mind this being. So I'll go here to modern office building with dynamic facade pattern in a contemporary city square. Now I'll copy this because I can always change the prompt a little bit just depending on what results I get. And if I don't like it, I can always change some of those inputs. I can also change some of the details here. So I'll go here to render, and it'll take about a minute or two to give me a result. All right, so at the end here, I got this result, which I'm really happy with. It puts it within the city, and it gives you a really good sense of scale on how this would look like in a setting. So if you wanted to go ahead and try this tool, check out the link that I have below with the referral code. You can get a discount for using it free at the beginning and also a discount for signing up.